we can predict the frequencies at which standing waves will occur by combining the expression with that related wavelength to the length of the string with the equation for the speed of a wave on a string. If we remember the wave equation that says that the speed of a wave is equal to the frequency times the wavelength, we can rearrange this equation by dividing by wavelength to get that the frequency is equal to the speed divided by the wavelength. Now the speed we can replace with the square root of the tension divided by the mass per unit length. And 1 over the wavelength we can substitute for that n, the number of antinodes, divided by twice the length of the string. So we get a prediction for where we have to vibrate the string, at what frequency do we need to vibrate the string to get these standing wave patterns. So if we're going for a certain number of antinodes, we take that number, divide by twice the length of the string, and then multiply by the square root of the tension force divided by the mass per unit length of the string. These standing wave patterns are referred to as harmonics. The first standing wave pattern, where n is equal to 1, so there is one antinode, this is known as the fundamental frequency, or the first harmonic. So if we calculate the frequency for that particular mode, then that is the fundamental frequency. Now the second standing wave pattern, where we have two antinodes, this is n equals 2, and the wavelength is the full length of the string. If we use our prediction equation for finding the frequency, we'll see that we get a frequency that's twice the fundamental frequency. So this is known as the second harmonic, or the first overtone. So this second harmonic frequency is twice the fundamental frequency. We can keep going if we have 3 antinodes, or n is equal to 3. Then that frequency is 3 times the fundamental mode, and we call this the third harmonic, or the second overtone. So we can ask the question, where should we place a finger to hear the second and third harmonics of a plucked guitar string? What we want to do by placing our finger is to create a node, so that the string then vibrates in one of these standing wave patterns. You can watch the next video to find the answer to this question.